Okay, now you've seen most of the things that when we're dealing with probability really just boils down to figuring out how many ways different things can happen. So in section 5.3, we're going to talk about counting rules and ways we can basically figure out how many ways something can happen. So the first thing we're going to do is look at what's called the fundamental counting rule. It's a very simple rule. Such as says if one event can occur m ways and a second event can occur in n ways, the number of ways the two events can occur in sequence, that means one after the other, is m times n. And this rule can be extended for any number of events, so not just 2, but 3, but 4, but whatever. So if we look at this first problem, it says an access code for a car security system contains 4 digits, 0 to 9. The first digit must be even. How many possible access codes are there if the digits can be repeated? Well, it says the first one can be even, so if we think of all the numbers from 0 to 9, 0, 1, 2, all the way to 9, then only 4 of those are even, namely 2, 4, 6, and 8. So the only possibilities for the first digit of this code would be 4. There are 4 possibilities. Now the rest of the digits can be repeated, and they can be any of these 10 digits. So the second digit can be any of the 10 numbers. So this one is the first digit, 4 possibilities. The second has 10 possibilities. The third has 10 possibilities. And the fourth has 10 possibilities. So that means there's a total of 4,000 different access codes. And of those access codes, we know that the first one has to be even. Now this can change, the number will change if you start to limit it. Like for example, if we don't repeat the digits, so I don't want to use maybe a code of 2222, well then I still need an even number to start with, so there's 4 possibilities. But now for the second digit, there are only 9 possibilities. Because remember, I've already used one of the digits. I've already used one even number for my code. Then I'll have 8 possibilities, because I've already used 2 numbers, and then I'll have 7 possibilities. So 4 times 9 times 8 times 7 is 2016. So by not repeating, you can see we almost cut our number of options basically in half. Okay, so let's try one more. A license plate can contain 2 letters and 4 numbers, essentially. How many license plates are available if they cannot be repeated? And the letters cannot be repeated and the digits may be repeated. So we have 2 letters. So we'll say letter, letter. And then we have 4 number possibilities. And I'm just going to see how many different possibilities there are for this code. Now the letters cannot be repeated. So for the first letter I have 26 choices. So since one letter has already been used, there'll be 25 choices for the next one. And then for the numbers, it says we can repeat them. So for every one, there are 10 choices. So 10, 10, 10, and 10. And so to find the total number of license plates, we just multiply these numbers. So 26 times 25 times 10 to the 4th is going to give me 6,500,000. So there are over 6.5 million license plates with this combination. So as you can see from these first couple examples, a lot of multiplying to get the number of outcomes. One kind of thing that we'll try to shortcut this with is sometimes we'll use what's called a factorial. So a factorial is just essentially repeated multiplication down to the number 1. So for example, if I have 5 factorial, and this little explanation point is a factorial, 5 factorial just means 5 times 4 times 3 times 2 times 1. There is a factorial sign under your math number menu on your TI calculator. So if you hit math, go right to your number thing, then you'll find your factorial. Under that same menu, you'll also find the permutations and combinations we will talk about on the next page. Two other very important rules when arranging objects is what are called permutations and combinations. So a permutation is an arrangement of a certain number of objects in a specific order. So the key word here is in a specific order. Okay? So if I was picking 2 people out of 3 just for a random group or something, that's really not a permutation because the order doesn't really matter. If I was picking 2 people out of a group of 3 and I was going to put one of them to be the president and one of them to be the vice president of some sort of organization, that would be a permutation because the order does matter. So the permutations formula is pretty simple, and it basically talks about how many different ways are there to arrange n objects in a specific order if we're taking r objects at a time. So there is a total of n objects, and then we're taking a group of r of them. Formula, n permuted r times equals n factorial over n minus r factorial. Now there's certainly a button on your calculator that does this. It's called Math PRB. It's under that same math menu that we did the factorials earlier. So that's a really nice way to figure out what those are. I'm going to do them by hand because they're not super hard to do by hand. Because just remember that we know 5 factorial is 5 times 4 times 3 times 2 times 1. 10 factorial is 10 times 9 times 8 all the way down to 1. So the first thing we got to make sure is we got to make sure that it is a permutation. We got to make sure we do want something in an order. So this first example says for a job opening, a company is seriously considering 5 applicants. How many different ways are there to rank the 5 applicants? So this idea of ranking actually does matter. Because if we're ranking the people, well then of course it's going to matter because the first person is going to be the first on our list and the second person second, versus just a random grouping. So we have 5 total applicants, and we want to arrange all 5 in a specific order. So that's 5P5. So this is my n, this is my r. So if I plug it in, I get 5 factorial over 5 minus 5 factorial, n minus r. So that's 5 factorial over 0 factorial. Now 0 factorial is an interesting number. It's not 0, as you might guess, because if it was 0, this is undefined because you can't divide by 0. 0 factorial is always defined to be 1. And then 5 factorial we know is 5 times 4 times 3 times 2 times 1. So 5 times 4 times 3 times 2 times 1 is 120. So there are actually 120 different ways to rank these 5 applicants, assuming the order matters. Having one person first, one person second, one person third. And so on. So let's say we only want to rank the top 3. So let's say I only want to pick 3 people out of this 5. So I'm going to leave 2 people out. And then of those 3 people, I want to rank them. Well, that would be 5P3. There's my n, there's my r. And I'll show you how you can kind of work with these factorials. So this is 5 factorial on the top. And it's 5 minus 3 factorial on the bottom, which is 5 factorial over 2 factorial. Well, here's how I work them. Well, I know this is 5 times 4 times 3 times 2 factorial. Because I can really stop my factorial at any point I want. I'm just going to go down to 2. I know it's 2 times 1, but I'm just going to stop here. And the reason I will, because if I have a 2 factorial on the bottom, these are just the same number, so they will cancel out. In this case, since the next number is 1, it's probably kind of a silly thing to do, but it will help us later on. So 5 times 4 times 3 is 60. All right, let's look at this last problem. It says a news director wishes to use 3 stories on an evening show. One will be the lead story, one will be the second story, and one will be the closing story. So just from that, I know that the order does matter, so it'll be a permutation. If the director has 8 different stories to choose from, how many possible ways can the program be set up? So we have 8 different programs. I know it's a permutation because the order matters, because the lead story, second story, and the last story, closing story. So it's 8P3. So if I use the formula, that's 8 factorial over 8 minus 3 factorial. So it's 8 factorial over 5 factorial. Now, here's how we can do these factorials pretty simply. I'm going to use that same trick I used above. So this is 8 times 7 times 6 times 5 factorial. I'm just going to stop there. And the benefit of stopping there is I can now cancel these out. So then I just have 8 times 7 times 6, which is 336. The second kind of counting technique we'll talk about is a combination. Now, a combination essentially is when you're just selecting objects when order of arrangement is not important. So if I have 5 students and I just want to pick a random group of 3, how many different groups of 3 could be pulled out of those that are not in any particular order? So it's very similar to the permutation formula. NCR, n choose R, is n factorial over n minus R factorial, which is the same. But the thing we add is we divide by an extra R factorial. So the computations get a little more complicated, but not terrible. So again, combinations, the order does not matter. The permutations, the order does matter. So let's look at this first example. A bicycle shop owner has 12 mountain bikes in the showroom. The owner wishes to select 5 of them to be displayed at a bicycle show. So we just want 5 of the 12. So we don't really care what order they're in. We just want to pick the 5 out of the 12. How many different ways can a group of 5 be selected? So that's going to be 12 C5, which I use the formula is n factorial over R factorial over n minus R factorial. So in this case, it's a little different because we get 2 factorials on the bottom. We get a 5 factorial and a 7 factorial. Now the way I compute this is I'll do the same kind of idea. I'll start with 12 and I'll start going down until I get to one of the factorials. The first one I get is 7 factorial. So on the bottom I know I have a 7 factorial as well, which these will obviously cross out. But I also have a 5 factorial, so I have a 5 times 4 times 3 times 2 times 1. So I can certainly cross out the 7 factorials, but I get a bunch of numbers on top and bottom. So what I do is I just try to cross them out as integers. For example, 5 times 2 is 10, so I'll just cross out the 5 and the 2 and the 10 on top. 4 times 3 is 12, so I'll scratch out the 4 and 3 on the bottom and the 12 on top. So really I'm just left with 10 times 9 times 8, which in this example, 10 times 9 times 8 is 792. Now again, you can, of course, use your calculator for this, but using the factorial notation is really not too tough. So in this second example, it says, a club of 7 women need to choose a committee with 3 members. How many different possibilities are there? Well, there are 7 women, and I don't really care the order of these this group, so it's going to be 7 choose 3. So that is going to be 7 factorial over 3 factorial times 4 factorial. So if I simplify it, it's 7 times 6 times 5 times 4 factorial all over 3 times 2 times 1 times 4 factorial. So I leave the last one, the bigger one, so I can cancel it out, and then I expand the other one. But if you look, I got a 3 times 2 and a 6 on top, so I can cross those out. So I have 7 times 5, which is just 35. So if you have 7 members and you need to have a committee of 3 people, there are 35 different committees you could have, so different arrangements of people. All right, this next one says a club of 5 men need to choose a committee with 2 members. So same idea. So if 5 choose 2, which is going to be 5 factorial over 2 factorial, and then 5 minus 2 factorial is 3 factorial. So if I expand this, it's 5 times 4 times 3 factorial over 3 factorial, and then we have 2 times 1. So the 3 factorials will cancel. 4 over 2 will leave me with a 2, so I'm just left with 5 times 2, which is 10. So with a group of only 7 men, not quite as many committees can be formed with 2 members. Now we can actually put these together. So this last problem says a club consists of 7 women and 5 men. A committee of 3 women and 2 men is to be chosen. How many different possibilities are there? Well, the key word in here is really and. We want both of these to occur. So really this takes us back to our fundamental counting principle. We'll figure out how many ways this committee can happen and how many ways this committee can happen. And the fundamental counting principle says we can just multiply that. So I want a committee of 3 out of the 7 women, so that's 7C3, which we actually did above, times, because the fundamental accounting principle says multiply, 2 out of the 5 men. So 5, choose 2. Well, since I know that's 35 for that one and 10 for that one, there are 350 committees of 5 people consisting of 3 women and 2 men. All right, just a couple other examples. If a class has 19 females and 5 males, and we need a group of 2 males and 2 females, how many ways are there to group it? So again, it's an and. We need 2 males and 2 females, so same idea. So we'll do 19, choose 2, times 5, choose 2. And you can put this in the calculator, you can do the math, but this one's going to be 171, and this one is going to be 10. So this is going to be 1,710. Our last problem is kind of a little bonus problem. It says, how many arrangements are there of the letters in zoo school? So we can switch this all around. I can make the word school zoo. I can make the word, OOL and then zoo ska or whatever I want. But a lot of them will be the same word. Like if I switch, say, this O and this O, well, I still get the word zoo school, right? So the different ways you can arrange it, well, we have 9 letters in zoo school, I believe. So we're basically trying to put them in a specific order. So that would be a permutation, so that would be 9p9. So that would be 9 factorial over 0 factorial, which is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All over 1, because remember we said 0 factorial is 1. And so that ends up being 362,880. And that's fine. There's a lot of different ways to arrange those letters in a specific order. But the second question is actually an interesting one. It says, how many distinct words can be formed? So if I just switch those 2 O's, that doesn't really give me a new word. It just gives me the same word with a different orientation. So if I want to figure out how many distinct words that could be formed, so I don't want to count zoo school twice, let's say, then I'll still start with all the different totals there could be. So we know there's 9 factorial total. But I want to divide how many repeated letters they have. Now we have only 1 repeated letter, it's O. So I want to divide 9 factorial by 4 factorial. Because what that'll do is that's going to divide out. It's going to reduce the number that have those repeated zeros. So that's going to turn out to be 15,120. So a big reduction by not wanting to repeat those letters. So a little bit about combinations and permutations. Try the assignment. If you have questions, obviously bring them to class and we can discuss them there.